Hey, it's Mr. Farrell here. Just wanted to make a video to help students who are virtual as they're trying to do this experiment write-up. So you should have your experiment write-up pulled up here. This is for the force, punch, and kick experiment. All right, so as you may be aware, we're working with Super Smash Brothers, the video game, in class right now. So everybody in class chose a character that they wanted to focus on, and they are looking at the moves of that character, trying to calculate the force of those moves. So we're going to read through the overview and procedure a little bit, just so we can get a good sense of what's going on in the lab. And then we're going to talk about how to do some of the experiment write-up and where you're going to get your data from. Okay, so the force, punch, and kick experiment says in this experiment, you're going to calculate the acceleration of your punch and your kick. All right. Then you will use that acceleration to calculate the force of a punch and kick for your Super Smash Brothers character. And you're trying to figure out which of your Super Smash Brothers characters' moves is the strongest, okay? I wanted you to test 4 of the characters' main moves, but as it happened in class, we only ended up being able to do 2 of the characters' moves. So you're gonna do 2 of the moves, not 4 of the moves. If you had heard me talking about that in class previously, and you were wondering, how come we're not doing all 4 moves? We're just gonna do 2 of them, okay? So we're gonna scroll down to the procedure and kind of look at that, all right? So in the procedure, it's saying that you're going to use a motion sensor, all right? We've been using motion sensors in class in order to do this experiment. And students will use the motion sensor, hook it up to their computer, hook it up to the Vernier graphical analysis software, and as students do their Super Smash Brothers character moves, they're going to punch at the sensor or kick at the sensor, and that sensor is going to record important information that's going to help them calculate the acceleration and eventually the force of the character's move. All right, so now that we've read the procedure, we're going to take a brief pause so we can write our introduction for the lab write-up, okay? So your introduction has 3 parts: a relevant title, a summary of what you're doing or what you did, and your hypothesis, okay? So for your lab write-up, just come up with a relevant title. It could be something related to Super Smash Brothers, something related to kicking, punching, force, any of that works, okay? Next, you're going to write your introduction. And again, just before you start writing it, remember, as you write this stuff, just copy this lab, make a copy of it by going to File and Make a Copy. And then you'll be able to use this kind of as a template for putting your own information in. So as you do that, you're going to want to delete the section that says Materials and Overview so that you can write your own introduction, all right? So once you have all that done, right, feel free to pause this video at any time as you get stuff done. But once you have that done, you made a copy of the document, you deleted the materials and overview section, and you're starting your introduction, right? Make sure to write a relevant title, all right? Next thing you're doing is you're writing a summary. So again, in this lab, we're using motion sensors to measure characters' moves. In order for me to be specific, you're using motion sensors to measure the velocity of the moves. You're going to use that velocity to measure the acceleration, and you're going to use the acceleration to help you calculate the force, okay? So you're using the motion sensors to measure the velocity, using that velocity to calculate the acceleration, and using the acceleration to calculate the force of the character's move. Now for you, you're going to have to write a hypothesis as well after you write that summary. Your hypothesis can go in the same paragraph as the summary. All right, now the character we're going to be focusing on is the character Little Mac from Super Smash Brothers. Little Mac has some super strong punches. He's got a haymaker punch where he punches straight down, and then he's got a like a super punch where he charges up and punches forward. So those are the 2 punches we're going to simulate within this lab, okay? So for Little Mac's punches, you have to decide which punch you think is going to be stronger. And that's going to be your hypothesis. Do you think that the haymaker punch is going to be stronger, or that the straight punch is going to be stronger? You can go ahead and write that down for your hypothesis. All right. I'm going to keep going. And again, you can pause this video at any time. So now we're going to scroll down to the data analysis section. So in the data analysis section, you've got 3 different data tables that you're working with. Okay? So the data tables are showing you character move 1, character move 2, and character move 3. Okay? For character move 1, we are looking at the velocity of Little Mac's move, and we're going to write down the time that it took Little Mac to do that move. Now again, we are doing these moves. So I have one of my sensors hooked up to my computer, all right, and I'm going to punch at the sensor, and I'm going to use that to kind of graph and see what's going on. So let me go ahead and pull out a sensor for you. All right, just so we can get a sense of how this works. All right, so what you see on the screen here is the Vernier graphical analysis software. So as I hit collect for my data, and I go ahead and punch at the screen, or punch at my sensor, you can see that we get a graph that shows my velocity as I'm moving toward the sensor with my punch. Now I would go to one of the points on this graph where I punched at the sensor, and it would tell me my velocity, and it would also tell me the time it took for me to do the whole move. So what I'd be recording in my data table is the velocity and the time for that move. All right, now I'm going to go ahead and close that. So in your data tables, we're doing each move 3 times. So we're going to write down the velocity 3 times, and we're going to write down the time 3 times, okay? Same here with the final velocity for our second move. So this first one is for the haymaker. The second one is for the straight punch. Now, we're not going to go through all the data, but I'm going to give you 3 different velocities and 3 different times. You're going to have to calculate your average velocity and your average time. In order to do that, you're going to add up all 3 velocities and divide by 3. And you're going to add up all 3 times and divide by 3. That's how you calculate the average. So you add up all of these, divide by 3, add up all of these, divide by 3. You're going to do that same thing for the second character move. Once you have the data for all 3 trials, you're going to add up all 3 velocities and then divide them by 3. Add up all 3 times and then divide them by 3. And that'll give you that data, okay? Now, the last piece of information you're going to have to do is you're going to have to calculate the acceleration of the character, all right? In order to do that, we'll cover those equations in a little bit. All right, so if you look at this lab, all right, so after you calculate the averages, you use that velocity to calculate the acceleration, all right? So the acceleration equation is earlier in the lab report, but again, just writing it here, it is going to be that average velocity that you calculated divided by the average time that you calculated. So that's for move 1. And then you're going to do the same thing for move 2. Average velocity divided by the average time. All right? And that'll give you the acceleration for move 1, the acceleration for move 2. All right? Now for your character, his mass is going to be 41 kilograms. Okay? So now you got your mass, you got your acceleration for both of your moves. In order to calculate the force, you're just going to use that equation again from earlier in the lab. Force equals mass times acceleration. And that'll give you the force of each of the characters' moves. All right? And then at that point, You have your force. All you got to do is write your conclusion. All right. There's information on the conclusion in the rubric. All right. Also, make sure to write your 2-sentence explanations of your data tables. So those 2 sentences should cover what is this data table showing me, and what is the important information in the data table. For example, for data table 3, the important information that it's showing you is about the forces. That's the most important information. What was the force of these? But it's also telling you, you know, the mass, acceleration, all of that information. All right, so just basically summarize the table in a sentence or 2, and then tell what the important information to pay attention to is. Do that for each table, and then write your conclusion, which is where you say whether your hypothesis was supported or not supported, which data table gave you that information. Spoiler alert, it's going to be data table 3 because your hypothesis was about which move was stronger. So this data table is telling you which move was stronger. And then you use a real world application, which is from this experiment, what did you learn, or what was something that was new information to you, and how do you think that applies to the real world? All right, so if you have any further questions, you can reach out to me, but this is just to help you get started on doing that lab work. And again, you will have the data for trials 1 through 3 for both of the character moves for the straight punch and the haymaker. All right, and you'll have to calculate the averages and then the acceleration and all. All right, thanks, have a good one.